So we are starting a new topic now, that is series. In this topic, we are going to be looking at three subtopics, that is binomial expansion. The other is arithmetic and geometric progression. Okay. So these are the progression that we are going to be discussing in the same chapter. But for today's class, we are starting with binomial expansion. Okay, now let's try to understand the basics first. Why is there a need of binomial expansion? Let's try to understand that. Bi means two terms. So if you look at the sum of the two terms, 1 plus x, and if I'm just adding this, okay, the complete power is 1. So the result is simply going to be 1 plus 1x. But then when I have 1 plus x, the whole thing square. So this is same as 1 plus x being multiplied by 1 plus x. And if you do the maths, you are going to get 1 plus 2x plus x square. Okay. Then when you multiply this result by 1 plus x again, okay, when you multiply 1 plus x square with 1 plus x, you're going to get 1 plus x, the whole thing cube. Remember, bases are same, powers are going to be added. So if I want to evaluate 1 plus x cube, or I want the expansion of 1 plus x cube, what I'll do is I'll multiply the expansion of 1 plus 2x plus x square, okay, with 1 plus x again. So I'm going to get, after multiplying, I'm going to get this as my final answer. And if I want 1 plus x, the whole thing to the power of 4, I will simply take the expansion of 1 plus x cube, which is this, and I'm going to multiply this with 1 plus x again, and I'm going to get this result. But how long am I going to keep on doing this again and again and again? So you can see that the terms are increasing at every step. So it's not advisable, or it's not sensible to multiply the brackets each and every time. What if I want 1 plus x to the power of 11? So that's going to be a very tedious working. So in order to save time, we are going to be using binomial expansion that I'm going to be introducing now. But before I do that, I just want you to make some observations. If you factorize this, you get 1 plus x, the whole thing square. If you expand this, you get 1 plus 2x plus x squared. So these terms are basically called the expansion of 1 plus x to the power of 5. Notice that the first term is 1. Okay. And if this is just a constant term, that means that x is to the power of 0. Then x to the power of 1, x to the power of 2, x to the power of 3, x to the power of 4, and x to the power of 5. Okay, guys, these are the terms. So 1 plus x to the power of 5 is actually going to have these 6 terms. How many number of terms are there in 1 plus x to the power of 4? You can just count them. 1, 2, 3, 4, 5. There are 5 terms. So the first observation that you can make over here is that when we are expanding, the number of terms are going to be 1 more than the power of the bracket. Okay. So if you can see that in 1 plus x cube, there are 4 terms. Although the power is 3, but the number of terms are 4. Okay. And the expansion is being done in the ascending order over here in this example, particularly. The powers of x are increasing. Over here, this was x to the power of 0, then x to the power of 1, then x squared, x cubed, x to the power of 4, and x to the power of 5. The powers of x are increasing. What are these called? So can I say that 1 is a constant term? There is a term 5x is the second term in the expansion with x has a power of 1. The term in x square is 10x squared. The term in x cube is 10x cubed. The term in x4, x to the power 4 is 5x to the power 4. And the term in x to the power 5 is 1x to the power 5. These numbers are basically the coefficients. Okay. Now these numbers can be used to study one of the favorite popular triangle called the Pascal triangle. Okay. I'm just explaining Pascal triangles for your reference. There are no questions being asked on Pascal's triangle, but it's better that you should know this. Okay, so if I write down the coefficients over here, starting off with 1 plus x to the power of 1. The coefficient of the first term is 1, which is just 1, the constant term. This is coefficient of x to the power of 0. And the coefficient of x to the power of 1 is 1. Then the expansion of 1 plus x squared yields this 1 plus 2x plus x squared. So the first term is 1. The first coefficient is 1. The second coefficient is 2, then 1. Similarly, 1, 3, 3, 1. So 1, 3, 3, 1. 1, 4, 6, 4, 1. So 1, 4, 6, 4, 1.
So do I have to know this?
No, you don't have to memorize this. You just need to like listen to me for now for 2 minutes so that you understand why are we doing this. You are going to notice over here that you can get the second row by just, okay, so you need to understand this, that the first term is always going to be 1 in the expansion of 1 plus x. And the last term is going to be 1. Okay. And there is going to be a triangle being made. How? The next term in the row is going to be the sum of the previous row numbers. So 1 plus 1 is 2. 1 plus 2 is 3. Okay. So 2 plus 1 is 3. Now the next fourth row, 3 plus 1 is 4. 3 plus 3 is 6. 3 plus 1 is 4. And ones are there on the extreme ends. Okay. Now, if I ask you to predict the next term, so for example, if I don't want to multiply this 1 plus x to the power of 6 with 1 plus x, sorry, if I don't want to multiply 1 plus x to the power of 5 with 1 plus x again to get the expansion, you can make use of Pascal's triangle to get the coefficients. How? You guys know that the next term, the first term of the next sequence is going to be 1 again. Okay,
Sir,
and
I
there is
could
going to
say
be
that
1
it
again
will
over
be
here.
6.
Just give me 2 minutes.
It
Yeah.
will be 6 and 20 and
Yeah. 5
12.
plus 1. So that's going to be 6. 10 plus 5. That's going to be 15. 10 plus 10, that's going to be 20. 10 plus 5, that's going to be 15. 5 plus 1, that's going to be 6. So if I want to write down the expansion, I'm going to write 1, the constant term, plus 6x plus 15x squared plus 20x cubed plus 15x to the power of 4 plus 6x to the power of 5 plus 1x to the power of 6. That's going to be the expansion. So I did not need to multiply, do the multiplication again and again. I can use the Pascal triangles to predict the coefficients. Okay, but this method is also not much preferable, because for that you will have to start from the top and then predict the next and then predict the next. So if I ask you what is going to be 1 plus x to the power of 11, then still you will have to do the expansion till 1 plus x to the power of 10 and then predict again. So it's a time consuming process. It's a tedious process. Okay, so the method that we are going to learn is going to be the shortest method and the preferred method, known as binomial expansion. Bi means two terms, so we are looking at a way of finding the expansion of the two terms. All right, we are looking at a way of finding the expansion of the two terms. Now, before we look at binomial expansion, I would like you to be familiar, get yourself familiar with these notations. Now, any number written with the factorial sign, this sign is the factorial sign. For example, 5 factorial, if you come across this term, this number 5 factorial, this simply means 5 multiplied by the number below that being multiplied by the number further below that. So 5 times 4 times 3 times 2 times 1 till you get 1. So 5 factorial is simply the product of 5 times 4 times 3 times 2 times 1. 6 factorial is simply 6 multiplied by 5 multiplied by 4 times 3 times 2 times 1. Okay. So n factorial simply means n multiplied by a value that is 1 less than n multiplied by n minus 2 and so on till you get 1. Okay.
Sir, what's n?
What is
1.
n? Okay, n is going to be now the power. Okay, these powers
Okay.
of that's n. Okay, I'll just make it clear over here. Okay, so now you need to understand this formula. Okay, I'll rewrite down the formula so that you are working with me. If I want to expand two terms, okay, let's say the two terms are A and B, and I want to expand this, the sum of these two numbers raised to a power of n. The formula that we are going to use is, okay, I'm just writing down the formula first, then I'll explain each and everything. NC0 a to the power of n minus 0. So n minus 0 is n. And second term, that's your first term. That's your second term. So b to the power of 0. This is going to be the first term of the expansion. Plus NC1. Then the next term is going to start with NC1. I'm going to explain what does this C means. NC1, first term to the power of n minus 1. Second term, that is b to the power of 1. Plus NC2, first term to the power of n minus 2. Second term to the power of 2. Plus NC3, first term to the power of n minus 3, b to the power of 3. And this is going to keep on going until you reach NCN, first term to the power of n minus n, second term to the power of n. I'll give you an example. So if we are asked to expand 1 plus x to the power of, let's say, 5. So over here, n is simply representing the power of the bracket, that is 5. The first term is 1 and the second term is x over here. Okay, now I will explain what does these value means, okay? But right now I'm just using the formula. Remember that this binomial expansion is only valid when you have integer values of n. In your syllabus, you are only be getting integer values. So can you just help me write down the first term for this? What should I write over here?
5C0.
5C0. First term
A
to the power of,
1,
that is 1.
5.
5 minus 0, that is 5. And
And then
second term is
power of
x
0.
to the power of 0.
X to the power of 0.
Okay. Plus the next term is going to be 5C1. First term, that is 1 to the power of 5 minus 1, that is 4. Second term is x. X is going to be power of 1. Plus 5C2. First term to the power of 5 minus 2, that is 3. Second term to the power of 2. Plus 5C3. 1 to the power of 5 minus 3, that is 2. X to the power of 3. Plus 5C4. 1 to the power of 5 minus 4. X to the power of 4. And the last term is going to be 5C5. First term to the power of 5 minus 5, that is 0. Second term to the power of 5. Now notice that you are going to end at 5C5 because you can't have 5C6. The expansion is going to end on NCN.
Could you repeat again?
I'm saying that the expansion is going to end at NCN. So 5C5, you can't have 5C6. Okay?
Okay.
All right. Now, I'm just further going to simplify this. But before that, I want you to make some observation. This is one of the term, this is the second term, third term, fourth, fifth, and sixth. Since the power was 5, the expansion is going to have the number of terms one more than the power. So the expansion is going to have 6 terms. Then you should also notice that the powers will always add up. The powers of the first term and the second term will always add up to give you the value of n. 4 plus 1, 5. 3 plus 2, 5. 2 plus 3, 5. 1 plus 4, 5. And 0 plus 5, 5. Okay. Now, I want you to use your calculator to evaluate 5C0. Everyone's calculator will have this option. Everyone's calculator will have this button of NCR. Okay, if you have the recent calculator, there is going to be a button on the third row from the bottom, the extreme button. The divide button will have NCR written with green color on the top. Do you see this option?
Yes, sir.
Okay, so this is what I want you to do. I want you to press.
Sir, yeah, I remember.
I want you to press
So you
5.
can do it with calculator?
Yeah, you can do this with calculator. I want you to press 5 with the 5 in the calculator, then press shift button and then press this divide sign. Okay, shift and divide. So it's going to activate the NCR option. There is going to be a C written on your screen, calculator screen. And then you're going to type in 0. So what does 5C0 comes out to be?
1.
1. Okay, so the value of 5C0 comes out to be 1 in the calculator. Is everyone getting 5C0 as 1 in their respective calculators? Zores, are you getting 5C0 as 1? Do you find the C option in the NCR option in the calculator?
Yes, it is above my division sign.
Yes, perfect. What about you, Abdul Rahim?
Yes, sir. Sir, I know. Yeah.
Okay, so 5C0 is 1. 1 raised to the power of 5 is 1. And x raised to the power of 0 is 1. So the first term is 1. Now, I want you guys to calculate 5C1 in the calculator. 5C1 will be 5. 1 to the power of anything is 1. X to the power of 1 is x. So the term is going to be 5x. Then you're going to evaluate 5C2. 5C2 comes out to be 10. 1 to the power of anything is 1, x square. 5C3 now. 5C3 is 10 again, x cube. 5C4 is 5, x to the power of 4. And 5C5 is 1 again, so x to the power of 5. Now compare these terms with the expansion that we did earlier. Aren't we getting the same answer? Yeah. So instead of multiplying, I was able to use this formula to get the expansion. And this expansion is valid for any power of n. No matter how high power is, it's valid for any power of n. The only restriction is that this must be a positive integer value. This expansion formula is only valid when you have a positive integer value. Okay.
Sir, we can just write the number and write this CR5, 6 thing. Then we just get the answer, yeah?
You are going to do the working as I have shown you on the screen. You're going to write this term first, and then you're going to evaluate the final answer.
I would say 5C, that's it.
5C0, the first term is going to be 5C0.
Question.
Yes.
Sir, let's say for let's say R 1, 2, 3, 4, we memorize those triangles and we just show this section here. Will they not give us the whole marks for it or not?
But you will not be able to solve questions of power of higher order. So
Yes,
for
sir.
example, you first of all, the chapter name is binomial expansion. No? So they expect the working from the expansion of these terms using the binomial expansion formula. The reason I explained Pascal's triangle over here was to make you appreciate how helpful this formula is going to be, how easy it's going to make your life. Because Pascal's triangle, if you only remember this part of the Pascal's triangle, but what if you have been asked to evaluate 1 plus x to the power of 12? So you will have to do a quite number of steps, and not necessarily you are going to get 1 plus x. You could have gotten 2 plus x to the power of 5. Then all these values are going to be changing. Okay.
So, okay, what if I use the pyramidal method? It will be good or bad compared to this one? A plus B and
Which method do you want to use?
it's okay to use any of both of them, or it's okay to
No,
use
no,
any
no,
of
no.
them?
It's not okay. We are only going to be going with this method. Okay.
Is there another way, or like from the calculator or something?
No, but we are basically we are using calculator to evaluate these. Once we know the formula and we make use of the formula, then you can just use the calculator to evaluate the coefficients, help you evaluate the coefficient. That's it. Okay, we are going to do a couple of examples and it's going to be far more clear now. So I want you guys to try this question over here. Okay, I'm leaving the screen over here. I want you to use the same formula and try to expand this 3x plus 2 to the power of 3. Now the first term is not 1. Okay, now the first term is 3x over here. Just do the first part. Okay, so the first term over here is 3x and the second term is 2. The expansion is going to be, the power n value is 3. So the first term is going to be 3c0. First term to the power of 3 minus 0, that's 3. And the second term to the power of 0 plus 3c1. First term to the power of 3 minus 1, that is 2. And the second term to the power of 1 plus 3c2. First term to the power of 3 minus 2. Second term to the power of 2 plus 3c3. First term to the power of 3 minus 3, that's 0. Second term to the power of 3. Will there be any other term?
No.
No, because we have reached the last term NCN. Okay. And when there are when the power is 3, there are only going to be 4 terms in the expansion. Okay, now you can use your calculator to evaluate this. 3c0 is going to be 1. 3 to the power of 3 is 27. X cube. 2 to the power of 0 is 1. So the first term over here is going to be 27x cube. Plus 3c1 is 3. 3 square is 9. 9 times 2 is 54. So 54x square. 3c2 is 3. 3 times 3 is 9. 9 times 4, 2 square is 4. So that's going to give you 36. 36 to the power of 36 times x to the power of 1. And the last term is 3c3, which is 1. 3 to the power of 0 is 1. X to the power of 0 is 1. So that's all 1. And 2 to the power of 3 is 8. So that's the expansion. And you can see that the expanded terms are in the descending powers of x. Over here, the power was 3, then 2, then 1, and then x to the power
Sir,
of.
how did you get 27x cube?
Take out your calculator, evaluate 3c0. What is 3c0 coming out?
1.
1. Okay, 1 times, what is 3x, the whole thing cube? Won't it be 27x cube?
Yeah, it should be 27x.
And 2 to the power of 0 is 1. So 1 times 27x cube times 1 is 27x cube.
Okay, okay.
Okay. So these are the these are the terms in the expansion of 3x plus 2 to the power of 3. So if I ask you what is the coefficient of x square, you're going to say 54. What is the expansion of x in the expansion of 3x plus 2 to the power of 3? In its expansion, the coefficient of x is 36. What is the term independent of x in the expansion? The term independent of x is 8. So you should be able to answer these kinds of questions. Okay. Are we clear with the working?
Yes, sir. Clear.
Okay. Now I would like you to know how do we calculate these values of NCR without using the calculator. The examiner expects you to know this formula of NCR, okay, because sometimes there are going to be questions in which you may not get the value of N, or the question is designed in such a way that you need to find the value of N. Okay, I'll show you the question, but just for now, if I want to evaluate NCR, the formula that you are going to use is this is equal to N factorial over N minus R factorial times R factorial. Now, I'll show you with the example. For example, I need to evaluate, I'll take the above example. For example, I need to evaluate 5C3. Now, my calculator gives me the answer for 5C3 as 10, right? I'll show you how to get this value of 10 without the calculator. So I need to evaluate 5C3. I'll use a different color. 5C3. Now the N value is 5 and the R value is 3. So the numerator over here is going to have 5 factorial divided by 5 minus 3 times 5 minus 3 factorial times R factorial. R value is 3. So 3 factorial. Okay, so this means 5 factorial divided by 2 factorial times 3 factorial. Is everyone with me till this step?
Yes, sir.
Okay, now what was the meaning of 5 factorial? Can I express 5 factorial as the product of 5?
This is a formula to solve the whole thing.
No, this is the formula to calculate just any expression in the form of NCR. So for example, if I want to find 5C3 value without calculator, I can use this formula to calculate it. The formula is N factorial over N minus R factorial times R factorial. So 5 being the value of N and 3 being the value of R. So 5 factorial over 5 minus 3 factorial times 3 factorial. Okay, so now just answer with me. 5 factorial can be expressed as 5 times, 4 times, 3 times, 2 times 1 divided by 2 factorial times 3 factorial. Okay, can I say, guys, can I say that 3 times 2 times 1 is the same as 3 factorial?
Yes, sir.
Yeah. So can I just simplify 3 times 2 times 1 and 3 factorial? It's the same.
Yeah.
So the answer simplifies down to 5 times 4. What is 2 factorial going to be?
2 multiplied by 1, that's 2.
2. So 5 times 4 is 20. 20 upon 2 is 10.
Oh, so it's 10. Okay.
Okay.
Do I have to show these working, or we can just simply use the calculator?
I'll show you how the examiner asks questions, but right now just do it for your understanding. Do not understand
sure.
it with the perspective of solving a question and answering the question in the exam. I just want you to take the knowledge out of it, that how do we calculate this? The value that you get in the calculator is actually calculated by this formula. Okay. Now you can just try this one. Let's try 8C5. Okay, what is 8C5 going to be? If I use the formula, it's going to be 8 factorial upon 8 minus 5 factorial times 5 factorial. Agreed?
Yes. So 8 factorial over 3
8
factorial.
factorial over 3 factorial times 5 factorial. Now, if I want to expand 8 factorial, I can expand it till 8 times, 7 times, 6 times, 5. Can I write? Can I stop at 5 factorial over here? Because I know
Yes.
after this, it's going to be 5 times, 4 times, 3 times, 2 times 1. The reason I'm stopping over here is because I see that the denominator has also 5 factorial. So I can cancel this out. So the answer is simply going to be 8 times 7 times 6 divided by 3 factorial. What is 3 factorial? It is 6. So if you cancel this out, 8 times 7 is 56. So now take out your calculator and evaluate 8C5. What do you get in your calculator?
56.
Are you getting 56?
Yes, sir.
Okay,
Yes,
Yeah.
perfect. All right. Okay. Now I would like you to take a picture of this. Take a screenshot of this
So
page.
you send this out to the class, yeah?
Yeah, I'll send it, but right now I want you to take a picture of this as well.
Okay, yeah, sure. We'll
We
solve
have
it,
done
inshallah.
part A. I want you to try part B in a similar way. Okay.
Yeah.
And I would like you to try these 2 questions as well. I'll be answering your queries in the next class as well. So just try these
Assalamu alaikum.
questions. Walaikum Assalam. All right.